and S waves. We're going to go over that. And you've already copied down your volcano diagram that was projected on the screen, which is also in the lesson attachments. If you lose yours for some reason, you need to reprint it. It is there for you. It also is there. Do not forget that the blank copy is in lesson attachments. So if you go to lesson attachments, you see the blank copy. How do you use this as a quiz? See if you can fill in the blanks and then check it with your notes or check it with what's here. Any questions for that? Okay. All right, then today we are going to just quickly look at earthquake, what's shaking. So that's this sheet here. You need to take this out from Friday. Everyone got this sheet on Friday. Some of you completed it, some of you did not, but that's okay because we're going to go over it right now. And we're just going to go right through the class to go over each portion of it. So starting with DQ, I'll give you about 30 seconds to get it out. It's up on the screen. After you finished your project on Friday, you got this sheet. Where's yours? You started working in Apex to complete it. All right. Starting with Shania then. Earthquakes occur as a result of plates grinding past one another and forming. Well, tell me now. What does it form? Once the earthquakes grind past each other, they break. What does that break called? When the plates break, what is the break called? A fault. Now notice how your notes are set up. The next portion is talking about formation of earthquakes. So earthquakes form when two plates do something, stress builds, rocks break, energy release, and aftershock. Each portion gives us more detail about what they are. So talking about earthquake formation, and we talk about two plates, what is it that we're talking about when two plates try to move, Antasia, past each other, but can't because rocks are in the way? What are we talking about when we talk about stress builds for earthquake formation, Aaron? Go ahead, Aria. Read it. Read us the whole thing. Good. As stress builds in the ground, rocks bend slightly, storing massive amounts of energy. What do rocks breaking have to do with earthquake formation? Janie. Very good. When that stress is at a certain point, that's like you. If your stress levels get to a certain point, you finally crack and lose it. Just like the earth. The stress reaches a certain point, the rocks break, and the plates move. What does energy release have to do with anything? Jamia, try it out, even though you didn't get to it on that day, but try it out. Earthquake. This is exactly what it's talking about. Earthquake formation. Energy release. The rocks were bent, regained their original shape, releasing the stored energy and causing an earthquake. Nope. It's an earthquake. Now looking at aftershock. What is that, Antasia? Read that to us. Good. Not all energy gets released. Some stress may still exist, and that's when you have an aftershock. All right, now looking at earthquake location. Shania, about 90% of earthquakes happen near. What do they happen near? Aaron? The boundaries of the plates, the plate boundaries, along the edges. Mostly in what zone, Shania? We only talked about one zone. Starts with an S. Maybe you should get your notes out. Maybe you should get your notes out. Now. You're wasting our time. You haven't earned any. There hasn't been an opportunity to. Help us out, Aaron. Subduction zone. This is where oceanic crust slides underneath continental crust, produce both volcanic and earthquakes. Earthquakes happen in the blank of the continental U.S. Where? In the middle. All right, the structure of an earthquake. We have something called an epicenter. Delandis, what's an epicenter? What's an epicenter? Where's your note sheet from Friday? Because this was one you kept raising your hand and said, I'm done. What do I do when I'm finished? What do I do when I'm finished? And you were, so get it out. This is what we're going over. I know, but you need to have it out so that makes sure your answers are correct, and you need to have it in front of you. So what is an epicenter? I'm sorry? Delandis, speak up and put your head up. Sit up. What? The surface right above the earthquake? Does that make sense? Come on, people. Is it the surface above an earthquake? Aria, what do you have? So is that the sense? Yes, that is exactly the same thing. So come up here, Jamario, and point to the epicenter on this picture. Is the center of the earthquake on the Earth's surface. Right there. Let the record show that he is pointing to this area here. That is the epicenter. What is this line right here? This is a fault. The focus, then, is the location on the fault where the slipping of two plates start. So this is where they begin to break. So again, it's the location on the fault where the slipping of two plates start. And that would be represented by this star. That star is really that impact, that breaking. Yes. It is the location on the fault where the slipping of two plates start. So it's actually where the plates begin to break. Or where they begin to move on the fault, not break, where they begin to move. All right. The last part, you had to play a little game, but you still need to know this information. I'm going to call out the questions. You call out the answer. You do not need to raise your hand. The Richter scale measures the... Nobody got it? Magnitude. What is the magnitude? What does the word magnitude mean? Huh? Intensity, the strength. So the Richter scale measures the intensity or the strength of the earthquake. What type of wave caused the most damage to buildings in earthquakes? It's either the P wave or the S wave. How many of you did not get to the race? If you got to the race, then you should have the answers. The only way you can win the race is if you got the correct answers. What do you have, Janie?
Oh, no,
No, it's the S wave. Did you finish the race? Oh. S waves cause the most damage to buildings and earthquakes. Raise your hand if you did not get to the game. We did not finish the game? All right, there we go. Okay. Earthquakes are caused by stress building up between the plates. Delandis should be giving me answers because he's the only one that said he finished. Then why aren't you giving me any answers? Then I'm looking for you to give answers since you're the only one that finished. Yes. It's the stress building up between the plates. Earthquakes are caused by the stress building up between the plates, number 3. Number 4, Delandis, read us and give us the answer. Read it, the whole thing. So it doesn't matter where you are in relation to the epicenter. That does not determine how intense the earthquake is. Why do earthquakes and volcanoes both happen at the same areas? You should be able to answer this without having to look at the game. Why do you think they happen in the same areas? What do they both have to do with? Plates doing what? Moving. The plates move, it's going to cause a break. That's an earthquake. And it's going to open up and release what? Magma. That's a volcano. So they both cause plates movement. And you just finished this portion on your notes. Most earthquakes happen near subduction zone. They both cause plate movement. All right, once you're finished writing that, I want you to go ahead and put your earthquake review sheet in front of you, but we're going to go to the second to last page. So we're looking at the page that looks like this. It is titled P and S wave. All right. Now we're going to look at the first one together, and then I'm going to have you look at it with your group. So, in looking at this diagram, this is a diagram that is made by what type of machine? A seismograph, but then what measures this? What measures the intensity of an earthquake? You need to look at your notes. You just wrote it down. A Richter scale. So this is measuring the waves of an earthquake. Just like if you were in the hospital or someone was in the hospital and you had to get your heart rate measured, you would see your heart rates measured in waves. A woman that's having a baby, her contractions would be measured in waves. Your monitoring your breathing would also be something like this. So this also monitors the strength or the intensity of the wave. Jamario, sit up. But this happens with the seismogram, and a seismologist is the one that measures this and looks at this information. And we have two different waves. You have a P wave and you have an S wave. Which one is more intense, causes more damage? S wave causes more damage. So that's the first. You have the initial rumbling, and then you have the real trouble that comes along with it at the S wave. Some areas only experience the P wave. Some areas experience both the P and the S wave. So we're going to look at this. Take a couple seconds right now and look at Station X. These are 3 different stations experiencing an earthquake. Look at Station X and see if you by yourself can fill in the chart below. But I want you to do it on your own first. About 30 more seconds because it doesn't take that long. Aaron, for station X, what is the first P wave arrival time? Time. What time, Jamia? 12:01. Notice this says time scale minutes after noon. Noon is here. The pre-wave starts right here. So what time is it? 12:01. So we should have 12:01 written here. I don't have one. I know it does. I have to fix it. What time is the first S wave arrival time, Aaron? Is it? 12:02 and 30 seconds. Notice it's in between 12:02 and 12:03. Half of a second, half of a minute is 30 seconds. Does that make sense? Okay. Take a moment and fill in your lag time. Mario, what is lag time? What does that mean? The time in between. So what is the lag time, a PS wave lag time for station X? A minute and 30 seconds. Can't write it that neat when I'm writing on the computer. All right, with your group, I want you to go ahead and figure out station Y and station Z. About 30 seconds. All right, Jeremiah, for station Y, what's the P wave arrival time? 4? That's not a time. 12:04. P wave starts right here, so we should be putting 12:04 here. What is the S wave arrival time, Jamario? 12:08. What's the lag time, Aquarius? Between 12:04 and 12:08, how much time has passed? 4 seconds. Between 12:04 and 12:08, Antasia, how much time has passed? 4 minutes. All right, for station Z, Jenny, 12:03 for the P arrival time. The S arrival time, Shania, 12:06. The lag time, Delandis, look up at the screen. The only one that's not highlighted in right here. 3 what? 3 minutes. Everyone good with that? All right. Then let's look at the next page because we do need to be able to read this graph. I'm going to give you about 5 minutes to work at 9, 10, 11, 12, and 13 with your group. You are working. You're not going to the bathroom. You are working on these 5 right now with your group. Work. And sit there and work. Sit there and be quiet. No. No. Go to the door. You need to put some hand sanitizer on. One more minute. Group A, be prepared for 9. Group B, be prepared for 10. Group, what is this? Group C, that side, be prepared for 11. The Aquarius, be prepared for 12. And on this side, Aria and Tasia and Jeremiah, be prepared for 13. Aaron and Jenny, how far does P wave travel in 2 minutes? All right, so we have P wave here. We have 2 minutes. You said 600? That would be incorrect.
Is it 800?
No.
After 2 minutes, when you go up 2 minutes, you're right here. How many miles is this? Look at the screen. What number is right here? But what's on their screen, though? I mean, what's on their paper? 500. It's the closest to 500, but I don't know where you guys got 100. 100's way over here, but this is 500. But you said 100. Yes. 500. Can't be 100. Oh. No, I would say it's closer to 5. All right. Number Jamia and Jamario. How far does the S wave travel in 11 minutes? 2,000 miles. Well, here's 11 minutes. Here's the S wave. 2,000 miles. That is correct. Is that a far distance? Yes, it is. From here to New York, it's 700 miles. That's 10 hours away. So imagine 2,000 miles. Honey, that's 10. We're only on 10. Number 11. Shania, well, actually, Delandis, since you're finished. How long does it take a P wave to travel 2,000 miles? 6 what? 6 minutes. 6 minutes, 2,000 miles. P wave. All right. Aquarius, number 12. How long does it take the S wave to travel 1,500 miles, also known as 1,500 miles? You have 1,500. We're looking at the S wave. 9 minutes would be correct. Antasia, Aria, and Jeremiah. As distance from an earthquake increase, do the P and S wave arrive closer or further apart? Further apart, and you see this big gap in between as distance increases. Yep, when it begins to slow down. Yep, yes. Yeah, right. All right, lastly, you have a map that looks like this. It tells us that the epicenter is represented by a what? By an X. So here's our epicenter. 1, 2, 3. Antasia, that side of the table in Aquarius, you guys will have seismograph 4, Shania and Delandis 3, Jamario and Jamia 2, Janie and Aaron 1. You are to link which graph represents what town. Take about 30 seconds. I'll be asking you for the answer. Read the instructions if you didn't know exactly what you should be doing. The instructions are on your paper. Aquarius, you might want to be talking to your group members. Delandis, get your head up off your arm and talk to your partner. And talk to your partner. It's not about you just having your answer. All right. For seismograph 4, which is this one here. You said New Orleans. Why? Shh. Sir. Say that this one is for New Orleans because it's farther away from the epicenter. Do you think here any buildings will be damaged? Why? What is that one? It doesn't have what? There's a little bit more of a simple answer. What's not pictured here? There's no what? There's no S wave. From your notes, you know the S waves are the ones that cause damage to the buildings. All right. Seismograph 2, that's Jamia and Jeremario, sorry. You say that this one is for Pittsburgh? Why? It's not as close to the epicenter. There's a place that's closer. So, yes, that's definitely correct. Seismograph 3, Shania. I can't hear you. Louisville. That's a silent. And why do you choose that? Okay. Delandis, will there be any buildings damaged here? That's wrong then. Pick the right answer. Will there be any buildings damaged here? Delandis, with this being the correct graph for Louisville, will there be any buildings damaged here? Why, Shania? S waves cause damage, and this is showing that there were S waves that have occurred. For Janie and Aaron? New York, obviously, that's our last one, and that's the closest. Will there be any damage here? Yes, there will definitely be some damage here. Any questions for this? Yes, New York has the most damage. All right, what you're going to be doing right now, you are going to get your review packet out that I gave you. You're going to be working at it because tomorrow we will be going over and we will be playing a game to review that information. This will be stuff that will be included on your test or quiz that you will have that will include volcanoes and earthquakes once we finish talking about volcanoes. So take this time to work at it because your homework is to review, study this review sheet.